So, good day everyone. I am Maureen Sumido, one of the reporters of Group 9, and we are going to discuss about the nano world. So, bago ako mag-proceed sa aming main topic, let me discuss first what does the word nano mean. So, nano came from the Greek word nanos that means dwarf. It is a prefix used to describe 1 billion of something. So now let's talk about what is nanotechnology. Nanotechnology is the science and engineering of small things, in particular things that are less than 100 nanometers in size. It includes physics, chemistry, biology, engineering, biochemistry, biophysics, earth and environmental science, and also material science. The intention of nanotechnology is then to use this phenomena for the design, characterization, production, and application of materials, structures, devices, and systems. Ang nanotechnology is ginagamit to create materials and devices with diverse applications such as nanomedicine and nanoelectronics. And according to the TED Talk of Ray Kurzweil, he talked about the future of humankind with nanotechnology. So, hindi naman natin mapagkakaila na ang nanotechnology really help us in a lot of things that made it possible for us to do such things in an easy as possible way. But, nai-imagine nyo ba na ang nanotechnology is magka-create ng technological red blood cells that can replace human red blood cells? So, if curious kayo, yes, it is possible with the help of nanotechnology. It does sound amazing, pero it is also terrifying. Since hindi naman perfect ang technology, given that it malfunctions, it sometimes stops responding, and even shuts down. With that, we all should be aware of the terrible consequences of having a machine inside our body. So, hindi lang naman dito umiikot ang buong pag-uusap, hence, it is just a way for us to not forget, and it also serves as a reminder kung ano ang pwedeng mangyari with the use of excessive technologies. Here are some examples of products with the use of nanotechnology na ginagamit natin sa pang-araw-araw. The first one is computer. Nanotechnology has a massive contribution to the major advances in terms of computers and electronics. Nanotechnology leads to faster, smaller, and more portable systems that can manage and store a large amounts of information that we are currently using today. The second one is sunscreen. Nanotechnology is also used sa paggawa ng sunscreen na most of us uses every day. It improved UV blocking efficiency due to their increased surface area to volume ratio, or we also call it as SPF that protects our skin from damages due to UV rays. And the third one is medicine or yung mga gamot na iniinom natin. So sa furnitures naman, sa pag-assemble and pagmamanufacture nito by coating, varnishes, upholstery, as well as the composite and plastic materials, furnishing a home sometimes has a feature of nanotech. So ang nanotechnology or nano is divided into two parts. The number one is nanotechnology or yung diniscuss ko kanina, where researchers develop and apply materials at this scale to develop new products and methods. And the second one naman is nanoscience, where the researchers learn about the chemical and physical properties of materials at the nanoscale. So materials at 1 to 100 nanometer are called nanostructures. So ang nanostructures, ito yung mga smallest things that can be made. So, nanoscience will further be explained by the next reporter, Miss Simene. She will talk about nanoscience, its principles, and practices.
Before we discuss the principles and practices of nanoscience, let's first have a brief explanation about nanoscience. So, what is nanoscience? Nanoscience is the study and use of extremely small materials, typically ranging from 1 to 100 nanometer in size. A nanometer is 1 billionth of a meter, making it about 100,000 times thinner than a human hair. At this nanoscale, material have unique properties that differ from their larger bulk form. opening up new possibilities for applications in various fields like medicine, electronics, and energy. So, bakit nga ba mahalaga ang nanoscience? Nanoscience is really important dahil kapag ang isang material ay napakaliit o nasa nanoscale, ang mga katangian nito ay nagbabago at nagiging iba mula sa karaniwang anyo nito o sa bulk material nito. Halimbawa ay ang ginto. Sa malaking peraso nito, 'di ba, ay kulay dilaw at hindi madaling matunaw. Ngunit kapag hinati ito sa nanoparticles, maaari itong magbago ng kulay at maging mas reactive. Ang mga pagbabago sa katangian ng material sa nanoscale ay nagbibigay daan para sa maraming bagong application na hindi possible sa mas malalaking sukat. In a very short explanation, nanoscience is the study of the world at an extremely small scale, where materials exhibit unique properties and offer new potential for innovative technologies and solutions to various global problems. So let's now move on to the principles of nanoscience. Nanoscience has three key principles: the quantum mechanics, surface area to volume ratio, and the top-down and bottom-up approaches. So first, let's further discuss the quantum mechanics. Quantum mechanics is the branch of physics that studies the behavior of particles at the atomic and subatomic levels, where particles like electrons and photons exhibit wave-like properties and behavior that differ from classical physics. At the nanoscale, the laws of classical physics break down and quantum mechanics become dominant. Ibig sabihin, ang mga electrons at iba pang particles ay nagbibehave ng iba kumpara sa mas malalaking bagay. May mga quantum effects tulad ng tunneling kung saan ang mga particles ay nakakadaan sa mga barrier na ayon sa classical physics ay hindi nila dapat kayang lampasan, at ang quantum confinement kung saan ang galaw ng mga electrons ay limitado o restricted na nagbabago sa kanilang optical at electronic properties. Next is the surface area to volume ratio. Nanomaterials have a high surface area relative to their volume, making them more reactive than bulk materials because a larger proportion of their atoms are exposed on the surface, allowing for more interaction. So, dito, sinasabi na ang nanomaterials ay may napakataas na surface area kumpara sa kanilang volume. Sa madaling salita, mas maraming bahagi ng material ang nakalantad sa ibabaw o sa surface kaysa nasa loob. Ang mataas na surface area na ito ay may malaking epekto sa kanilang reactivity at iba pang katangian. So, paano nga ba nagbabago ang katangian dahil sa high surface area? Kapag ang isang material ay nasa bulk form or malaking anyo, karamihan sa mga atoms nito ay nasa loob at hindi nakalantad. Samantalang sa nanoscale, ang material ay hinahati sa mas maliliit na peraso, kaya mas maraming atoms ang lumalabas sa surface. Dahil dito, mas nagiging reactive ang nanomaterials. Dahil sa nanoscale, ang mas malaking bahagi ng atoms ay nasa ibabaw at handang makipag-interact sa ibang substances. Ito ang dahilan kung bakit ang nanomaterials ay mas reactive kaysa sa parehong material na nasa bulk form. Halimbawa nito ay ang isang malaking piraso ng ginto. 'Di ba, pag malaki, hindi masyadong reaktibo. Ngunit kapag hinati ito sa nanoparticles, nagiging mas madali itong pumasok sa chemical reactions. Also, ang mataas na surface area ay nakakaapekto rin sa optical, electrical, and mechanical properties ng nanomaterials. Halimbawa, ang nanoparticles ay maaaring magpakita ng ibang kulay kumpara sa kanilang bulk counterpart dahil sa pagbabago sa paraan ng pag-interact ng light sa surface ng nanoparticles. So, example ng surface area to volume ratio. Kung meron kang isang malaking bulk ng iron at hatiin mo ito sa napakaliit na iron nanoparticles, ang iron nanoparticles ay magkakaroon ng mas malaking surface area na nakalantad sa oxygen o sa hangin. Dahil dito, mas mabilis itong kakalawangin kumpara sa malaking block ng iron. Sa madaling salita, Ang mataas na surface area ng nanomaterials ay nagpapalakas sa kanilang reactivity at binabago ang kanilang ibang properties, kaya nagiging mas versatile at useful ang mga ito sa iba't ibang aplikasyon tulad ng catalysis, medisina at electronics. Lastly, the top-down and bottom-up approaches. Nanomaterials can be created using two main approaches. First is the top-down. This involves starting with a larger material and breaking it down to the nanoscale through techniques like milling or lithography. Example nito ay yung silicon nanowires. Ito ay ginagamit sa paggawa ng microchips para sa mga computer at smartphones. Sa pamamagitan ng lithography, ang isang malaking silicon wafer ay hinahati at inuukit upang makagawa ng maliliit na wire na nasa nanoscale na siyang mahalaga para sa advanced electronics. And the bottom up. This involves assembling nanomaterials from individual atoms or molecules. This is like building a Lego structure from individual bricks. Self-assembly, where molecules spontaneously arrange themselves into ordered structure, and it plays a significant role. So, example naman nito ay carbon nanotubes. Ito ay ginagamit sa paggawa ng mga lightweight at matibay na materyales tulad ng sport equipment at nano devices. Ang mga carbon atoms ay nag-a-assemble at bumubuo ng cylindrical structures sa pamamagitan ng chemical vapor disposition or CVD. So now let's proceed to the nanomaterials characterization. Nanomaterial characterization is studying nanomaterials requires specialized techniques to visualize and analyze their structure, composition, and properties. These techniques include transmission electron microscopy or TEM. It is used to image the structure of individual nanoparticles. Second is scanning probe microscopy or SPM. It allows for the visualization and manipulation of individual atoms and molecules. Third is X-ray diffraction or XRD. It is used to determine the crystal structure of nanomaterials. And lastly, the spectroscopy. These various spectroscopic methods like UVBs, IR, and Raman provide information about the chemical composition and electronic properties. Let's now move on to the practices of nanoscience. First is the synthesis and fabrication. Developing new materials to create nanomaterials with specific properties is a core practice. This involves experimenting with different materials and techniques to control size, shape, and composition. Mahalaga ito dahil ang katangian ng isang nanomaterial tulad ng conductivity o reactivity ay kadalasang nakadepende sa laki at hugis nito. Kaya mahalagang mag-develop ng tamang techniques upang makuha ang nais na properties. Halimbawa nito ay gold nanoparticles. Sa synthesis ng gold nanoparticles, gumagamit ang mga siyentipiko ng chemical reduction upang makontrol ang laki at kulay ng nanoparticles na ginagamit sa medical imaging at cancer treatment. Second is the functionalization. Modifying the surface of nanomaterials to enhance their properties or add new functionalities is crucial. This can involve attaching molecules or other nanostructures to the surface. It is important dahil pinapabuti nito ang compatibility at interaction ng nanomaterials sa kanilang environment. Halimbawa ay sa medisina. Ang mga nanomaterials na ginagamit sa drug delivery ay maaaring functionalize upang targetin ang particular na cells tulad ng cancer cells. Third is integration. It is integrating nanomaterials into larger systems such as electronic devices or biomedical tools is a key challenge and area of active research. This requires careful consideration of compatibility and functionality. Mahalaga ito upang maging kapaki-pakinabang ang nanomaterials. Kailangan itong mailapat sa praktikal na mga device at teknolohiya, kaya mahalaga ang integration para maipatupad ang mga scientific discoveries sa totoong mundo. Halimbawa nito ay yung solar cells with quantum dots. Ginagamit ang quantum dots na integrated sa solar cells upang mapataas ang efficiency ng energy conversion mula sa liwanag ng araw patungo sa kuryente. Fourth, application development. Researchers are constantly exploring new application of nanomaterials across diverse fields, including medicine, electronics, energy, and environmental science. This involves translating scientific discoveries into practical technologies. It is significant dahil pinapalawak nito ang potensyal ng nanotechnology sa iba't ibang industry na nagbibigay ng mga solusyon sa mga problema tulad ng pagpapabuti ng healthcare, pagtaas ng energy efficiency, at pagpapabuti ng environmental sustainability. Halimbawa nito ay yung nanoparticles in drug delivery. Sa medisina, ginagamit ang nanoparticles para maghatid ng gamot ng direkta sa target cells. Gaya ng sa cancer therapy, ito ay nagbabawas ng side effects at nagpapabuti sa bisa ng paggamot. Lastly, the safety and environmental consideration. Because of their unique properties, nanomaterials may pose unique safety and environmental risks. Understanding and mitigating these risks is essential for responsible development and deployment of nanotechnology. So, it is important upang matiyak na ang paggamit ng nanotechnology ay ligtas at hindi nakakasama sa tao o kalikasan. Ang hindi tamang paggamit o disposal ng nanomaterials ay maaaring magdulot ng toxicity o environmental damage. Halimbawa nito ay yung silver nanoparticles. Habang ginagamit ito sa antibacterial coating, natuklasan na ang mataas na exposure sa silver nanoparticles ay maaaring makasama sa aquatic life. Kaya isinaalang-alang ang environmental impact nito bago ito gamitin sa large-scale production. So now, let's proceed to the next slide, which will be discussed by Ms. Tañedo.
So now, let's proceed na po sa next topic, which is advances in micromachines and robotics. So first is, what is micro and nanomachines? So micro and nanomachines, it refers to the fabrication of components or products with at least one feature size in the micrometer or nanometer scale. So, eto pong micro and nanomachines, eto po yung mga tiny devices or robots na dinesign para mag-perform ng iba't ibang task kagaya ng moving, sensing, or even pag-repair ng mga bagay. So, meron po itong mga potential uses gaya ng kaya nitong ma-target yung mga drug delivery, ma-monitor yung ma-monitor yung environment, at pati na rin sa mga inside body repairing issues, yung sa mga connected po sa mga tissues natin sa katawan. So, meron pong several classification methods na pinopose to classify micro and nanomachines. So, first, Mazuzawa. Mazuzawa, ito po, it summarized the micromachining technologies and categorized them based on different machining characteristics. So, ito pong Mazuzawa na to, so, second naman po, second is Madu. Madu, it classified micro and manufacturing technologies and the lithographic or non-lithographic techniques. And the last several classification methods is the Brinksmeer et al., Brucheux et al., and Q et al. So, ito naman po, it classified these technologies into two types. It namely microsystem technologies or MST and microengineering technologies or MET. So, yung MST po, ito po yung MST or the microsystem technologies. Ito po is generally employed to produce MEMS or microelectromechanical system such as photolithography, electroplating, silicon micromachining, microelectroforming, and chemical etching. So, by contrast naman po, yung MET or the microengineering technologies, ito naman po yung process na related sa mechanical machines, gaya ng cutting, milling, drilling, grinding, laser machining, micro-EDM, and FIB machining. So, ayon naman po kay Dimov et al. And Brusso et al., they classify these technologies on the basis of processing dimension. So, first is one-dimensional technologies. It includes micro-cutting, micro-grinding, micro-milling, micro-EDM, and FIB or the focused ion beam machining. So, ito pong first dimensional na to, these technologies po fabricate micro-components by performing material removal in a single dimension. So, second naman po is the two-dimensional technologies, which including photo or UV lithography, X-ray lithography, and electron beam lithography. So, ito naman pong technologies naman na po ito, pinafabricate naman po nito yung microstructures in a plane by employing mass. So, the last one dimension naman po is the three-dimensional technologies. It includes physical vapor deposition or the PVD, chemical vapor deposition or the CVD, microinjection molding or the MIM, and nano-imprint lithography or NIL. So, ito naman pong last dimension na to, na-employed po ito for conducting surface modification and deposition or fabricating volume structuring. So, now, let's proceed naman po sa recent development ng one-dimensional or ito po yung sa recent development po nila. So, yung first recent development po sa one-dimensional is the micro-cutting. So, micro-cutting, it refers to the process of mechanical micro-machining employing micro-tools with geometrically defined cutter edges to remove materials directly. So, ano nga po ba itong micro-cutting? So, ito po daw yung yung process daw po na to must be performed on ultra-precision machines or specifically design micro machines. Then, meron pong may mga typical process po ang micro-cutting. So, it includes po the micro-turning, micro-milling, micro-drilling, and micro-grinding. So, yung micro-turning po, ito po yung machining shape po nito is rotational convex shape with high aspect ratio, and ginagamit po yung technique na ito for creating small or accurate components gaya ng tiny gears, medical devices, or electronic parts. So, yung next naman po ng process is the micromilling. So, ito naman po, it has a convex and concave shapes, and it has a high aspect ratio naman po. Then, yung micro-drilling naman po, ito po is merong machining shape na round, blind, and through holes. Then, yung micro-grinding naman po, ito po, meron po siyang machining shape na convex and concave shapes of a hard, brittle materials. Then, the next recent development naman po sa one-dimensional is the micro-EDM or the micro-electrodischarge machining. So, ito po, EDM is a thermoelectric machining process that removes workpiece material through high-frequency, repeated electrical discharges between the electrode, tool, and the workpiece material. Both materials are submerged in liquid dielectric bath. So, ito pong micro-EDM, yung development po ng EDM is nag-directed po siya toward machining of features ng micrometric scale. Dahil po dito, nagkaroon ng malawakang paggamit ng micro-EDM sa fabricate micro-components, micro-tools, and parts with micro-features. So, next naman po is the laser micromachining. So, laser micromachining, it is widely used energy-based machining process wherein a laser beam is focused to melt and vaporize unwanted materials from the workpiece. It is an efficient microfacturing process because of its high lateral resolution, low heat, and high flexibility. So, ito naman pong laser micromachining. Ito po yung makabagong process na nag-i-employ ng laser beam para maskan yung mga workpiece at matanggal po yung mga material layer by layer gamit yung laser ablation effect. So, the last recent development naman po ng one-dimensional ay ang FIB machining or the focused ion beam. So, this machining it can fabricate complex micro and nano features using a focused beam ion with the cytoscanning electron microscopic or the SEM monitoring to remove unwanted workpiece material layer by layer. FIB can also be used to deposit materials via ion beam induced deposition when precursor gas exists. So, ito pong last na development na to sa one-dimensional. Ito po yung sa ngayon po, yung FIB micromilling technology, ginagamit na po siya ng malawakan sa mga semiconductor industry para ma-modify po yung mga electronic circuits at ma-prepare po yung mga transmission ng electron microscope or the TEM specimens. So, now let's proceed naman po sa advances in robotics. So, the first advances naman po sa robotics is yung swarm robotics. So, it is a new approach po to the coordination of multi-robot system which consists of large numbers of relatively simple physical robots. So, yung goal po ng approach na to is to study the design of robots both physically and sa kanilang controlling behaviors po. And kung paano sila mag-emerge at makipag-interact sa environment. So, the next naman po is yung advances po sa robotics is yung brain behind the robot. So, ito po, robots are becoming smarter wherein the intelligence of learning and knowledge sharing is incorporated. So, madami pong mga new technologies yung unexplored para mas maging adaptable at mas maging matalino yung mga robots natin to advance more. So, next naman po is edge computing. So, edge computing in robotics, edge computing allows robots to perform real-time analysis and decision-making locally without relying solely on cloud resources. So, dito naman po, mas pinabilis po nito yung pag-response, mas in-enhance yung privacy at security, at mas in-improve yung autonomy para po sa mga robotic system. And next naman po, itong Human-Robot Collaboration or HRC and Co-Creation. So, the trend of Human-Robot Collaboration or the HRC emphasizes designing robots to work alongside humans, complementing their skills and assigning in tasks. So, eto po, yung innovation po naman po sa area na to is nakafocus po siya sa safety and physical interaction ng mga tao sa robots. Then, next po is the advanced sensing and perception. Yung robotics po, robotics innovation is driven by advancement and sensor technologies. So, dito naman po, kasama po dito yung pagde-develop ng mga camera, lidar systems, yung mga tactile sensors and other modalities for perception. Yung mga sensors pong ito is nag-enable po sila sa mga robots na maintindihan ang kanilang paligid, makapag-detect po ng mga objects at maki-interact po actively sa kanyang environment. So, next naman po for the last topic is the applications of robots. So, dito po, yung sa application ng robots, industrial, professional, and military. So, first po, sa industrial robots, they are widely used in manufacturing. So, sa military naman po and police organizations, ginagamit po nila yung robots to assist sa mga dangerous situations. And lastly naman po, yung robots, nakakatulong po sila sa mga doctors para ma-achieve po nila yung more precision sa mga operating room para makapag-perform din po ng mas safe and less invasive techniques yung mga nagagamit po. So, in short po, yung robots po, it makes our life easier by handling jobs that are tiring, risky, or difficult, and inaalaw po nito yung mga tao na mas mag-focus po sa mas importanteng bagay kasi mas natutulungan po nila yung mga tao. So doon na po nagtatapos yung report ko. So now po, let's proceed naman po sa next topic which will be discussed by Miss Camella Torregoza. Thank you.
Moving forward for our last topic, cyber technology. Cyber technology refers to a wide range of digital tools, systems, and infrastructures used for the creation, storage, management, and transmission of information in cyberspace, o yung tinatawag na virtual environment where digital interactions occur. This includes hardware tulad ng computer at mga devices, software na nagpapatakbo ng mga systems, mga network na nagpapadali ng communication, cybersecurity na nagpaprotect laban sa mga threats, at mga advanced technology tulad ng artificial intelligence at machine learning na tumutulong mag-automate at mag-optimize ng mga process. In essence, cyber technology encompasses anything related to the cyber domain which involves first, computer and devices. Ang mga computer at electronic devices tulad ng laptop, smartphones, tablets at iba pang mga gadgets ay ginagamit para mag-access, mag-process at mag-share ng information online. Second is software. Software refers to operating system tulad ng Windows at mga application tulad ng word processors, web browsers at business tools that allows users para makipag-communicate sa kanilang mga devices and to perform specific tasks. Mahalaga rin ang may specialized software tulad ng data analytics, business operations, and content creation. Third is networks and communication systems. These systems form the infrastructure that allows information to be exchanged across vast distances. Under ng network and communication system, meron tayong tinatawag na internet. Ito yung global network na patuloy na nagko-connect sa milyon-milyong devices at nagbibigay daan para ma-access sa mga information. Next is wireless communication. Technologies like Wi-Fi, Bluetooth, at cellular networks that allow communication without using wires. Next is cloud computing, a model for storing and accessing data over the internet, offering scalable storage and computing power without the need for local infrastructure. And lastly, we have local area networks, or ito naman yung smaller scale networks na ginagamit sa mga specific na lugar tulad ng bahay, opisina at paaralan. Fourth, cybersecurity. As digital threats become more prevalent, cybersecurity is essential para maprotektahan ng mga system, data at users mula sa mga malicious attack. Kasama rito ang paggamit ng firewalls, antivirus software, encryption, at multi-factor authentication para labanan ng mga cyber attacks, data breaches, at iba pang mga online threats. And lastly is artificial intelligence at machine learning. Ang artificial intelligence at machine learning ay mga technology na nagpapabago kung paano pinaprocess ang data at pinapatakbo ang mga systems. Ginagamit ng artificial intelligence at machine learning upang mag-automate ng tasks to improve decision-making and to optimize the process. Halimbawa, sa cybersecurity, AI can explore unusual activities or possible cyber threats real-time, and these technologies are used to process data, improve automation, and optimize systems across industries, including in cybersecurity and network management. Now, cybernetics is often considered a foundational field within cyber technology, although it has a somewhat different focus. Cybernetics, it heavily influences and intersects with many areas of cyber technology, particularly in fields such as artificial intelligence, robotics, and autonomous systems. Now, let's talk about what is cybernetics. The term cybernetics was coined by Norbert Wiener in the 1940s from the Greek word kybernetes, meaning steersman or governor. Wiener aimed to create a unified theory of control and communication in both living organisms and machines. Cybernetics, though not a new concept, has become more widely recognized in recent years as organizations adopt technologies like AI, natural language processing, and robotic process automation to improve their compliance practices and regulatory outcomes. These technologies enhance cybernetic systems by enabling better monitoring, analysis, and decision making, allowing organizations to achieve greater efficiency and effectiveness in their operations. Looking ahead, cybernetics is poised to play an even more significant role in compliance or pagsunod sa mga regulations. It provides framework focusing for better understanding complex system, mga feedback mechanisms at mga self-regulating process o yung mga prosesong may kakayahang mag-adjust o mag-self-correct. At sa patuloy na pag-usbong ng mga technology tulad ng digital twins o yung mga virtual representation ng mga physical na bagay or process at smart contracts, ang cybernetics ay makakatulong to maintain integrity, transparency, at immutability of compliance-related data and transactions. Sa madaling salita, cybernetics will be crucial in compliance processes dahil makakatulong ito sa pagpapatibay ng mga systems to ensure that all data and transactions are accurate, transparent, and immutable. It can also be applied in areas such as anti-money laundering or yung mga illegal na gawain sa pera, data privacy or yung pagpoprotect sa mga personal information at cybersecurity or kaligtasan sa mga online threats na makakatulong to improve mechanisms for detecting and responding to risks in compliance. Here are the key concepts in cybernetics. Cybernetics incorporates several fields of science and includes the following key concepts. First is feedback loops. Feedback loops are a central concept in cybernetics. Ito ay ang pagpapalitan ng information between a system and its environment, allowing for self-regulation and adaptation. Feedback can be positive and amplifies changes, or negative feedback and stabilizes the system by correcting deviations from desired outcomes. Second is feed-forward processes. Aside sa feedback loops, binibigyang pansin din ng cybernetics ang importance ng feed-forward processes dahil ang feed-forward processes, it refers in predicting at pag-anticipate ng mga future events or conditions based sa mga available na information bago pa man ito mangyari. And using feed-forward mechanisms, it allows systems to adjust their behavior in anticipation, improving efficiency and reducing reactive adjustments. Next is control systems. Cybernetics emphasizes the design and implementation of control systems. These systems, ito'y gumagamit ng feedback loops to monitor and adjust the functioning of a system to achieve desired goals or outcomes. And these systems regulate various variables para ma-maintain ang stability and mapabuti ang performance, ensuring na ang system ay mag-ooperate within the desired parameters. Next is communication and information. Cybernetics explores how information flows within a system, how it is processed, and how it enables coordination among elements of the system. It refers kung paano tinatransmit, pinaprocess at ginagamit ang information sa pamamagitan ng iba't ibang elements sa isang system. And also, effective communication and information ensures the success of feedback loops and allows systems na mag-function accurately and para ma-achieve ang intended outcomes. Next, self-organization. Cybernetics acknowledges the ability of systems to self-organize and adapt. Systems can autonomously reconfigure themselves in response to changes in the environment or internal dynamics. The self-organization allows for flexible responses and improved performance in the face of uncertainties or disturbances. And lastly, adaptability and learning. Adaptability and learning in cybernetics mean that systems can adjust their behavior based on feedback and new information. Learning mechanisms such as machine learning allow systems to improve over time, optimizing performance and responding more effectively to future challenges. Moving forward in applications of cybernetics, we have first, risk identification and assessment. Ang cybernetics ay maaaring gamitin to identify at i-assess ang mga risks in compliance process. Gamit ang mga feedback loop at data analytics, cybernetic system can continuously monitor at i-analyze ang mga data to identify ang mga possible compliance risks. Sa pamamagitan nito, matutulungan ang mga organizations na maagapan ang mga risks na kaugnay ng non-compliance regulatory kaya't mas mabilis nilang matutukoy at matutugunan ang mga issue bago pa lumala. Second is real-time monitoring and detection. Cybernetics enables real-time monitoring of compliance activities and data. Sa pamamagitan ng automated feedback mechanisms, maaaring mamonitor at matukoy agad ang mga deviations from compliance standards, regulatory changes, and anomalies in data. This allows the prompt action para ma-address ang mga non-compliance issues and minimizing potential risks to ensure adherence to regulatory requirements. Next is control systems. Cybernetics emphasizes the design and implementation of control systems. These systems, ito'y gumagamit ng feedback loops to monitor and adjust the functioning of a system to achieve desired goals or outcomes. And these systems regulate various variables para ma-maintain ang stability and mapabuti ang performance, ensuring na ang system ay mag-ooperate within the desired parameters. Next is communication and information. Cybernetics explores how information flows within a system, how it is processed, and how it enables coordination among elements of the system. It refers kung paano tinatransmit, pinaprocess at ginagamit ang information sa pamamagitan ng iba't ibang elements sa isang system. And also, effective communication and information ensures the success of feedback loops and allows systems na mag-function accurately and para ma-achieve ang intended outcomes. That's all for our report. Thank you and have a great day ahead.